Hey folks, I wanted to do just a little more detail than what is in the week 3 video tutorial for homework. This will just kind of focus in on this problem here, and I think where the hang up is coming is with this interaction term. So let me detail this a little bit further for you. So this is the original data. What I have done is I've gone through the type of house that's being built here, whether it's a townhouse or a single family as a binary. So what I've done is I've gone over here and I've created this binary variable. I think I did this similar in my other video. So if you have a townhouse, that's now represented by a 1. And I use this logical statement up here. You can focus in on that if you want. I might have already done it in the file I left you. So all the townhouses are 1, single family is 0. And so the first thing we want to do here is we want to get the model to answer question 1, develop multiple regression model, for sales price as a function of lot cost and type of home without any interaction. So go up to data analysis, go to regression. The y variable should be, let me just redo this here. I might have been doing something else. Yep, so let's see, D19 to D187, which looks good. And then the independent variables, the x variables here are just going to be, let's see, lot cost and type of home again. And I'll show you what's going on again with that in just a second here. All right, so I've got the data in here, labels, because we have identifiers here at the top for each. And we'll put the output range, we'll keep it in this sheet so we can see the data. We'll put it right here. I don't think we need anything else. And so here's the initial model that you're looking for here. Let's see, adjusted R squared. So about 65% of the variation in selling price is being explained by lot cost and type of home. Let's see. So what the model would be here, what would the model be? It would be, there's your intercept. So intercept plus 3.66 times lot cost minus 73,847 times townhouse. Now, in this case, since you're using the townhouse as the value of 1 and the single family of 0, you can see what's going on here. If you were to go in and just estimate the cost or the selling price of a certain home, if you are buying a townhouse, you would multiply townhouse by 1, and basically you're subtracting $73,000 from the overall cost. The assumption there would be that the townhouse costs less money to build than a single family home. So if I had done this, and you can go back and do this if you want, let me make this other point here. If you're building a townhouse, the value of the variable here, the binary variable, would be 1. If you're buying a single family house, it would be 0. So you would not be subtracting any cost off whatever you got from the intercept plus 3.66 times the lot cost. That's just simple math. You can all play around with that. You can see how this would change if you went back and you made the single family house equal to 1 and the townhouse 0. But it's interesting that you would find that the cost would be the same regardless of what you're building. But that's just an interaction of the statistics here. Now, so that would answer question number 1. Now what we want is this interaction between lot cost and type of home. So I'm going to, since when you put this information into Excel, obviously you want all the independent variables together and all the dependent variable by itself. So I'm just going to put the interaction term. I don't know if I did this, I might have put it in a different spot, but this is just the same detail. So the interaction term here would be the product of the lot cost times the binary variable. And then you can just take that and you can pull this formula all the way to the bottom, and that will fill in. So what we're interested now, well, let me get the regression results first, and then I'll further explain this. So let's go, let's see, data analysis, regression again. The y variable doesn't change. The only thing changes here, I think, is this goes over to not F, but G. And we'll put the results here, and we'll hit OK. And so what we're doing here is, remember that we had 2 main effects not interacting in the first model. That was lot cost and townhouse predicting, I shouldn't say predicting, but describing variation in the price or the selling price of a house. Notice that if you look at the p-values here, both of them are very small. The test statistics are very, the magnitude is very large, and so both variables are significant. So when I say main effects, what I'm talking about here is lot cost and townhouse. If I go down here and look at the lot cost and townhouse again, what you find interesting here, and this is one of the values of regression. Let me get this so we can see both at the same time. The lot cost is still significant, you'll see here, but what you find is that the townhouse or the type of house that you're building is no longer significant. However, the point is that when you take the interaction between the lot cost and the type of home that you are building, what that is doing, and that should make perfect sense to you if you've ever built a house, is that interaction term, the type of house that you build is increasing the relationship between lot cost and the total price or total selling price of the house. And that would seem to make sense if you're building a single family home versus a townhouse. Again, you would expect to pay more money, assuming you build it on the same lot, you would expect to pay more money for a single family home than you would a townhouse. So again, the point that we want to make here is if we go back to the original model, the main effects, meaning lot cost and townhouse, in accounting for variation in selling price, are both doing that significantly. However, in the context, when we control for what again is, and I think I mentioned this term, moderating variable or moderating effect, what we're seeing is that this moderating variable, effectively that being the type of structure that you build, is increasing the relationship between the independent variables and the selling price. So that's the idea that we should take away from this. So I hope this should be very clear on how to produce these results. And again, the idea that really what we're looking for this week is, number one, how do we create a moderating variable that would, again, increase the relationship between the independent variables and the dependent variable? How do we get it? And again, it's basically just the product of two variables. And then to check whether or not it is playing a significant role, again, you can look at the p-value. And again, this just here while we're noting this, we always want to make sure we include the main effects to see which one, if we do have a significant moderating effect, what happens to the other main or the individual effects here of or the main effects of lot cost and townhouse. And again, you see that townhouse is no longer a significant contributor in describing the variation in selling price. However, it does strengthen the relationship as a moderating variable. So I hope that's helpful again, and it's probably more than you're interested in this week. This is the results, or these are the results that you're looking for to say yes, that you do have a significant moderating effect, and I believe that is, or interaction, to answer question 2, and then you can use the model down here to go and find yourself the selling price for a single family or townhouse. You can use, I don't care which model you can use one or the other, as long as you make sure that the variable inputs are correct. I think the only thing you want here, you have to do it for a single family home or a townhouse with a lot cost of $30,000. So that should wrap that up. So if you have any other questions, let me know, and I hope this helps. Thanks.